this week's episode of Seeking Proof, Finding Grace. I'm your host, Ron Campbell, and this week, as with every week, I want to thank you for joining us and remind you of the most important truth in the entire universe. God loves you. And I hope last week you joined in to hear that message of love as it related to the resurrection miracle on Easter weekend. Thank you so much for joining us for that. This week, we get back to the journey from the beginning of the universe to our little blue planet floating in space. Now, remember this portion of the journey that we're on. We had our first two miracles, the creation of the universe from nothing, the cosmological argument, the fine-tuning of the universe, the teleological argument, both of which showed the fingerprint of intelligence, the clear fingerprint of intelligence. My contention is that as we make this next phase of the journey, that what we will find as we go from the beginning of the universe to our little planet is that we will see the third miracle. Not because it's some God of the gaps kind of thing, but because what we will find along the way is exactly the opposite of the Copernican theory. And that's what we're going to see at many, many steps along the way. Now, each one of these steps individually doesn't necessarily raise to the level of being something miracle-worthy, you might say. So as we look at this, the cumulative weight of the entire journey is what tells the tale. So for example, last week, we started off in week number 1 looking at the first 3 different pieces. How the early stars formed, the early stars being ovens to create those heavier elements that we needed in the next generations to ultimately produce us, and the way those stars died, spreading those elements out so that they could be used in the next generations of stars to ultimately produce us. Then in last week's episode, we looked at 7 more items, number 4 through 10. Number 10 being the real money item in that list. Now again, along the way, for example, the fourth one is that we needed a spiral universe. Okay, or spiral galaxy, sorry. We needed a spiral galaxy. Well, that's not particularly difficult. There are a lot of spiral galaxies out there. But it couldn't just be any spiral galaxy. There were a great many things that we needed along the way to have just the right spiral galaxy to produce life down the road. Now, this is where it gets into that question. You remember before, many episodes ago, we talked about the multiverse. And the idea was, well, sooner or later, luck would prevail, and there had to be this cosmic winner. That somebody would get lucky, and we just happened to be the lucky winner of life's lottery. You're going to find that same argument being made here in some of these. Well, okay, so we happen to be in a spiral universe, just the right one, the right age, the right size, having just the right number of dwarf galaxies to feed on, just the right shape, just all of these different things. And you say, well, all of those things just happen to hit, and we happen to once again be the lucky recipient. It was true for the fine-tuning of the universe, and it's true once again here as we wind our way towards our little blue planet. The problem ought to start to become evident to you, though, as we make this portion of the journey. If you had to pile all this luck on top of itself to get us past the fine-tuning argument, and now we're having to pile additional luck on top of luck on top of luck to get us to the next step of the way, how much luck is it before our luck finally runs out and we recognize the fingerprint of intelligence? The Milky Way galaxy may be incredibly rare as it comes to specific things, but it's possible. And if it's possible, then it could have happened. And that's true. But as you reach that point of looking at the evidence that indicates that at some point in time, our solar system resided very near the center of the galaxy, where it got access to all of those that radiation that it needed. It had access to all of the various different supernova events that it needed to bring those building materials into our galaxy. The problem is if you stay there in the bright and shining center of the galaxy, well, that's a terrible place for life to eventually develop. At some point, our solar system moved from the bright and shining center of the galaxy all the way out to the Orion arm where we find ourselves now. See the picture up above? And it did so perfectly. You know, you would have thought that an event powerful enough to move our solar system would have just utterly destroyed it and ripped it apart. It would have blown it completely out of the galaxy altogether, or it would have just, moved it just a little tiny ways, but it would have still been in the danger zone. It feels like anything other than where we landed is a more likely candidate than us happening to land in just the perfect spot to support the long-term development of life. But yet here we find ourselves. So while we might be able to look past some of these events that have occurred so far, it feels like we're starting to stretch the bounds of credulity by looking at every single one and going, well, yeah, that could have happened too. I mean, I guess maybe, but one on top of another, how many more of these are we willing to look at before we say, no, this is no longer chance, this is clearly the fingerprint of design? So let's jump in tonight. And tonight we're going to talk about Newton's dilemma. You know, Newton recognized that the orbits of the planets themselves within the solar system, that there was something special there going on. And I want to talk about this by starting with a quote from Isaac Newton and really expanding on that and talking about what we're looking at here. He said, though these bodies, the celestial bodies, the planets, indeed persevere in their orbits by the mere laws of gravity, yet they could by no means have at first derived the regular position of the orbits themselves from those laws. Thus, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. So what Newton is referring to is, it is remarkably fortunate once again for us that when we look at our solar system, that every one of the planets has a perfectly designed orbit. And I'm using the word designed purposely in that regard. That the orbits of the planets seem to be far too well ordered for it just to have happened by chance. Because we have some rather large neighbors who might make our life incredibly miserable if they decided to move around a little bit. And Newton noted, yes, we can absolutely say that they're held in their current orbits by our sun and by a great many other factors that all balance out perfectly. And he says, obviously we understand how it works now, but it would be foolish not to recognize that there's no way this could have happened on its own. Clearly, the orbits of the planets in our solar system are ordered for a reason. What Newton didn't understand is exactly how remarkable the journey from where the solar system began to where we are today, how truly remarkable the journey has been, and what it really had to have looked like along the way. If he only knew what we knew now, he would double down on his statement, demand that we recognize the fingerprint of design. So let's talk about that as we go forward this week. So number one, Newton recognizes that the planets in the solar system all have elliptical orbits. All right, so it's not a perfect circle, but it's very near that. And recognizing that the orbits could have been many different ways. They don't have to be as perfectly centered around the sun as they are. It's no small miracle that Jupiter doesn't come by every once in a while and make our life miserable getting way too close to us. The same would be true for any other planet. It doesn't have to be anything nearly as big as Jupiter. Even if it was something as small as Mercury or even Pluto. We're leaving Pluto in, by the way. For the Pluto haters out there, Pluto's a planet, we're counting it. It's just the way it is. But any planet of any size getting too close is going to cause all sorts of problems. It'd be a whole new host of Hollywood disaster movies. But it's certainly going to be problematic. So the perfectly elliptical orbits of our neighbors in the solar system is the number one thing. This is what Newton is recognizing. And he's recognizing that these orbits are just too perfect to allow them to be chalked up to chance. Now the second miracle we have to address is our larger neighbors. Jupiter and Saturn are obviously the two big players in the solar system. And what scientists have come to theorize and understand is that Jupiter was likely the first of the planets to form, and Saturn was close on its heels. So Jupiter and Saturn and the other gas giants, as they formed, they laid the groundwork for us to have the rocky terrestrial planets that we have in the interior of the galaxy today. You say, okay, well, that was fortunate, but that on its own doesn't really, again, qualify as a miracle. Clearly, that can happen. True, and you're right about that. But then something interesting happens. So Jupiter and Saturn, many scientists believe, would have started much closer to the interior of the solar system than where they are today. But at some point, Jupiter and Saturn moved. And they moved from the interior of the solar system, which would be much more common, to where we currently find them. And again, you notice it's one of these interesting little journeys, just like our solar system's journey from the bright and shining center of the galaxy to where we are today. At some point in time, Jupiter and Saturn decided to take a little walk and to move out of the interior of the solar system and more towards the exterior where we find them today. And in the process of so doing, they did an enormous number of things. So Jupiter and Saturn, as they form and they begin to make this movement out from the interior of the solar system to the exterior, this movement happens because their orbits start to lock. And they start to develop a resonance to where they're moving too much in unison with each other. They're not locked exactly. One of them is orbiting the sun 1 time to every 2 times of its companion. But when that happens, they build up enough gravitational pull that it would have been detrimental to all of the other planets anywhere else in the solar system. So when this occurs, Jupiter and Saturn ultimately migrate outward. And amazingly enough, when they do, they clear the road. So what they're able to do as they migrate outward, they clear out an enormous amount of asteroids and planetoids and things like that are left here in the interior of the solar system that long term, again, would have made things very difficult for life here on our little blue planet. Isn't it fortunate the way it worked out? And they positioned themselves just where we needed them to be to again provide the next miracle along the way. Not only did they clear things out for the interior of the solar system, but they also, in their current position, serve as a wonderful barrier for our little planet as well. We're going to talk about the formation of our moon and a few other things in the weeks to come. But I think we can all remember back a few years ago, oh goodness, back in the mid-90s, no, it was late 90s, back in the late 90s when the Schumacher-Levy comet impacted Jupiter. The reason many of us remember that is not necessarily because of the comet's impact on Jupiter, which we did see amazing images of, but because the next year in Hollywood, we got all these disaster movies, or maybe it was 2 years down the line, with Armageddon and Deep Impact and all of these Hollywood movies. Armageddon, a great movie. But all of these movies with these disastrous asteroids impacts on Earth, well, the reason we got that was because of a massive asteroid impact on Jupiter. Had that asteroid hit us instead, it would be goodbye Earth. But thankfully, it broke apart and hit Jupiter because Jupiter's gravitational pull is so strong. Jupiter and Saturn sit out there on the outer edge of our, well, not fully outer, but further out in the solar system. And what they do is they're like, in football, you send your blockers out to block for your running backs. That's Jupiter and Saturn. They're blocking for the rest of us. And they do an amazing job of keeping debris coming in and hitting the rest of the planets here on the interior. So another wonderful miracle. I love the way this is put in Hugh Ross's book, Improbable Planet. These gas giant planets, Jupiter, Saturn, Uranus, and Neptune, with their respective masses, distances from the sun, and orbital configurations, not only served as the inner planet's protective fence, but also influenced Earth's mass, distance from the sun, and orbital features, all of which turned out to be just right to allow for the possibility and survivability of later advanced life. That is an amazing segue. So we talked before about this idea that Jupiter and Saturn kind of took up all of the various things that could have been used to make up the rest of the planets. And because of what Jupiter and Saturn used up from the available materials, we're left with rocky planets in the interior. So Jupiter and Saturn's formation and subsequent migration to the outer parts of the solar system have been tremendously beneficial. Could it happen on its own? Maybe. But when you combine it with everything else, it does seem to be a pattern starting to line up, doesn't it? The last thing we're going to look at tonight before we start wrapping up is, again, something called the late heavy bombardment. And at some point in time, after Jupiter and Saturn completed their migration, one of the things that has become apparent on our planet is early in Earth's development, there was a massive bombardment of meteorites and other asteroids and things like that hitting our planet. But what the late heavy bombardment did, and granted its timing was amazingly fortunate because if it would occur now, it would decimate all life on Earth. But it came at just the right time and it did a multitude of helpful things for us. At that point, before the late heavy bombardment, Earth was lacking many of the things that it really needed for the crust to really be able to support life, again, for a long-term favorable conditions for life. And this late heavy bombardment of materials that Jupiter and Saturn's migration outward helped to produce brought all of those materials into us at just the perfect time that we needed it. It helped seed the interior of the planet, and it helped really seed around the crust and things like that. And it brought everything from water to atmosphere to some of the radioactive materials and metals and things that we needed to really help support plate tectonics and life here on Earth. Again, just at the right moment to develop, to support the development of life here on Earth, something remarkable happens outside of the realm of anyone's expectations or probability. It came at just the right moment with just the right things. Isn't it amazing how all of that developed? So what we see once again as we look at this list of things this week, that as the early solar system formed, we got just the right things at just the right time as we see the planets themselves shuffling into just the right positions to support life here on this little planet of ours and to support it for a long-term development, which is exactly what we need where we find ourselves here where we are. I want to thank you for joining us this week. We're going to jump ahead next week and continue looking at this question of how things formed on this planet. And we're going to look at one of the next major events. Actually, we're going to back up just a touch to the formation of our moon, and again, how remarkably unlikely, and in this case, we're going to reach a level where divine intervention seems to be the only way possible that this occurred. Thank you so much for joining us. I hope you enjoyed this week's podcast. If you did, I hope you'll hit the subscribe button and the like button. You can find our podcasts on YouTube, Spotify, and iTunes, and you can always reach out to us on our website at prooftograce.com or via email at prooftograce@yahoo.com. Thank you so much for joining us, and I look forward to seeing you next week. Bye-bye.